I've drawn it. I've also put the center on there because they talk about radiuses, radii, so I'm going to need the center measurement on there. The target consists of 4 concentric circles. The inner circle has radius 3 centimeters. All right, let me draw that on quickly.
Brittany, is that better?
Okay.
Yeah.
Yes.
The radius of each larger circle increases by 2 centimeters. So when I go from this one, yeah, I guess that one would have a radius of 5. So I'll do it down here. That's the next circle up, if you like. Okay, that one's got 5. The next one up would have 7. And that makes the biggest circle 9. Okay. So as you can see, my scale is not the greatest, right? That there 3 is, well, that 9 is not 3 times longer, but it's close enough for us to make some judgments on here. Okay? A single dart's thrown at random, and it hits the target. So we assume their aim is good enough that they don't like fly up here or something like that. Okay, so they're somewhere on the dartboard. Find the probability that it hits within area P. All right, we'll start with that. Okay. Now, if you're working out a probability, right, you need to have favorable outcomes. I'm just going to write F, okay, over the sample space, right? The total number of things that can happen, okay? Now, in the previous question we were looking at, we had a weirdo area, shaded area up here, and a square down here. What's the total number of things that could possibly happen? How big is the dartboard?
So wouldn't it just be like 3 centimeters and then add them all together? Like 3 all
Well, let's try this. Because we're looking at areas, right? You got to be careful. I take it that the sample space, all the things that could happen, that's the whole dartboard. Is that okay? Do you set that? It's somewhere on there. Yeah.
Is the surface 24 centimeters?
Well, where does 24 come from?
You add them all together.
Okay. Now, adding these together. Well, now what are these? These are lengths, aren't they? Okay. But the dart could hit like on an area, right? So what I need to get for sample space and for favorable outcomes, they both have to be areas of some kind. Okay. The question is what areas? Now I said we're going to hit the dartboard somewhere, so I want the area of the whole dartboard. Area of the whole dartboard. Okay. So it's a circle, right? So what's the area of a circle? We just talked about this. Area of a circle. That's an angle. It's pi r squared, right? That's the area of a circle. Okay. So what's the radius of the whole dartboard?
9 centimeters.
It's 9, isn't it? So it'll be pi times 9 squared. We can do 9 squared, can't we? 9 times 9.
81.
It's 81. Well done. 81 pi. Okay. Centimeters squared. So that's what I've got on my denominator. That's what could possibly happen. Okay. Now I want the probability that it hits within area P. That's inside here. That's a little circle, right? So this is the dartboard area, right? Dartboard's area. What's the area of this part in here? Area of P. It's going to be pi r squared again, right? Except it's a different radius. Pi times, what will the radius of the small circle be? They gave it to us right at the beginning, right? It says the inner circle has radius 3 centimeters. 3 squared is 9, right?
Yeah.
So I've got 9 pi. So there is my favorite outcomes. That's the part that I want to hit, right? He's not going to get a bullseye, but within the inside is as good as it gets. Okay. So there you go. There's my probability.
Even the best one. Yeah.
Favorable over sample space. Can I cancel anything?
Yes.
I can, right? What can I cancel?
Pi.
I can cancel the pies. Bam, bam. There you go. Can I cancel anything else?
Well.
Where did we get this 81 from? Where did that number come from? It was 9 squared, wasn't it? So I could write 9 times 9 here, couldn't I?
And then can you get rid of it?
And I can get rid of a 9. Okay? So there you go. I don't think I can cancel anything else left because I've got 1 on the top. So it's 1 over 9. There you go. Does that make sense? See how we did it?
Yeah.
We worked out what the areas were, and then we just cancelled as far as we could. Yeah.
So, you know how you crossed out the 9 on the top?
Yep.
Why'd you have to put a 1 there?
Well, because it was the last thing left, I don't have nothing over 9. I've got 1 over 9. So I'm not subtracting numbers, I'm dividing. I divide, you know, when I have this, 2 over 6, okay? When I cancel here, it's saying this. You divide this by 2 and you divide this by 2. Well, 2 divided by 2 is not nothing, it's 1, right?
Yeah.
So that's why I write a 1 there. Does that make sense?
Yeah, okay.
Okay. Good question. Last part of this, it says find the probability that it hits within area S. So that's the outside boundary. Yes? How do I work out area S? It's if I shade it, it looks like this. That there, the green shaded area, that's area S. How can I work it out? Yeah, Amy.
2 by radius.
Say that again.
Is it like 2 times the radius?
Which radius are we talking about? Because there's quite a few, aren't there?
Is it 7 times twice?
Can I suggest, do you remember what we had before, where we started this lesson? It's quite similar to this, right? You had this guy, and you were interested in this area, this shaded part, right? So you're like, you got a big shape, in this case it was a square, and you cut out a circle. Cut out a circle and you're left with this shaded part, right? Well, this green part,
The area of the whole circle.
Yeah, it's-
is pi 7.
yeah, good. I've got to take the whole dartboard, which I've already worked out, 81 pi. And then I've got to take away this inside circle, which is radius 7. Okay, so here's the way I'm going to do it. What was this, part A or is it part 1? Part 1.
Yeah, you don't even need to work out few, so.
No, that's right. It's just there kind of as a,
Ah.
just being a bit sneaky.
Ah.
Yeah, I only need R. So here's my probability. To get this green shaded area, it's going to be the whole dartboard. Sorry, probability equals the whole dartboard minus the area of that circle.
Yeah.
Now be careful. I think the area of R actually means that strip. It doesn't mean a circle, but anyway. Now, like Kyle said, it's 49 pi.
Yeah, but
Okay. Yep.
you need like sort of to make a circle, sort of like match that area. You don't just get R, because even though R's a ring, you need the inside area to actually work out what.
Oh yeah, I see what you mean. Well, so I've done the circle that fits around R, so if you like, the whole thing.
I wrote
All of those layers.
like S ring equals, but
Yeah,
I
yeah,
think
yeah.
R circle instead of R ring. 'Cause it's
Yeah,
like-
okay, so yeah, that's fine. As long as you can distinguish between them, that's okay. So that's this, isn't it? 81 pi minus 49 pi, and it's still divided by 81 pi, because it can still hit anywhere on the dartboard. Yeah, and that's what 81 pi represents, the area of the whole dartboard. Can I cancel anything? I can still cancel pi, can't I? Okay. Now, be careful here. I got 81 minus 49 on 81. So before I do any cancelling the numbers, I should probably work out what 81 minus 49 is. Does anyone know what it is? I reckon we can do this in our heads, can't we? It's 32. You can sort of see it's like 80 minus 50, almost. So you know it's around 30, and then you sort of compensate with your numbers there.
28.
32 on 81.
That's close.
It was close. Can we cancel anything? We're done. That's it. Okay. So that's why don't cancel numbers too quickly. It has to be in common between everything. Right.